Oh no! The fall has caused bleeding. Do you know that when bleeding occurs, your body immediately activates an emergency response? Inside the blood vessel, the walls tighten to slow down the blood flow. Platelets rush in like tiny workers, moving quickly to the injured area. They stick together and form a temporary platelet plug to seal the wound. At the same time, the blood vessel narrows even more, helping to reduce blood loss. But the real hero working behind the scenes is vitamin K.
So, have you ever wondered where vitamin K comes from and how it is digested and absorbed? Well, vitamin K didn't just appear out of nowhere, but it comes from your meal, mainly from dark leafy greens such as spinach, kale, and broccoli, as well as fruits such as blueberries, blackberries, and kiwi. During digestion, vitamin K is released from food in stomach and small intestine. In small intestine, vitamin K, which is a fat-soluble vitamin, incorporates into mixed micelle via the action of bile and pancreatic enzyme. This tiny micelle then transported vitamin K to release the anterior side of small intestine and diffuse out from micelle, then enters the anterior side by passive diffusion. Inside the anterior side, vitamin K incorporates into chylomicron together with other lipid. The chylomicron are transported through lymphatic system via lacteal, then into the bloodstream. This chylomicron transported to the liver for storage of vitamin K.
Liver is the site where vitamin K performs its main function. Vitamin K is required for the activation of vitamin K-dependent clotting factors, which include factors 2, 7, 9, and 10. Clotting factors are proteins in the blood that works together in a step-by-step process to stop bleeding when a blood vessel is injured. These clotting factors are produced in the liver in inactive form. Vitamin K acts as a cofactor in a biochemical process known as gamma carboxylation. This process allows the clotting factors to bind calcium once they enter the bloodstream. When a blood vessel is injured, clotting begins through two pathways, the intrinsic pathway and extrinsic pathway. Both pathways then join the common pathway, where factors 2, 7, 9, and 10 help form a stable blood clot.
In the final stage of the coagulation cascade, prothrombin is converted into thrombin, and thrombin then converts fibrinogen into fibrin, forming strong fibrin fibers. When a blood vessel is injured, activated clotting factors, platelets, thrombin, and fibrin move toward the site of the damage. At the injury site, platelets become activated. They change shape, forming spikes that help them adhere to the damaged vessel wall. Activated platelets release granules such as ADP, prostaglandin, serotonin, and phospholipid. These substances recruit more platelets to the injury sites and amplify the clotting response. The platelets aggregate to form a platelet plug, and fibrin fibers weave around the plug, strengthening it. This results in a stable blood clot that seals the wound and prevents further bleeding. During clotting, vitamin K is used to activate clotting factors and is converted into vitamin K epocytes. The body then recycles vitamin K through vitamin K epocyte cycle, converting it back into its active form. This recycling allows vitamin K to be reused, ensuring continuous and efficient blood clotting. Gut bacteria also contribute by producing vitamin K2.